Body A of mass 4m moving with the speed u. Let we are having a body A having mass as 4m moving with the speed u. Collide with another body B. This is body A. B of mass 2m, which is at rest. That means initial velocity of B is 0. After collision, the fraction of the energy lost by the colliding body A. Friends, अगर हम यहाँ पर conservation of momentum डालें, according to conservation of momentum, right? According to conservation of momentum, momentum before collision of a body is how much? 4m into speed is u. Second body was rest, so 0 is equal to, let after collision, they are moving with velocity v1 and v2. Listen, let A is moving, they collided, and after collision, let the velocity of the 4m is v1 and the velocity of 2m is v2. So 4mu is equal to 4mv1 plus 2mv2. Got it? So if I'll solve it, then I'll get, if I'm interested to find the second body, how much it is having. Initial kinetic energy was 0, then after collision it is having some kinetic energy. So if I'll take it, this is u1. So I can write 2 taking common, u1 minus v1 is equal to v2. That means the velocity of the second body is becoming 2 whole into u1 minus u2. So u1 minus v1. Friends, from conservation of momentum से हम ये velocity पता लगा लिए. Now we are interested to find the conservation of energy. So from conservation of energy, because it is given, it is a elastic collision. From conservation of energy, initial kinetic energy is how much? Half 4m u1 square, which will be equal to, after collision kinetic energy, half 4m v1 square plus half 2m v2 square. By solving and calculating, I will get 2 into u1 square minus v1 square is equal to v2 square. Okay. And students, previously we have got, from here we have got 2 u1 minus v1. u1 square minus v1 square, you know, u1 plus v1, u1 minus v1. So by comparing that one, from equation 1 and 2, ये लिख सकते हैं 2 u1 square minus v1 square, so is equal to v2
So
is,
U1 plus V1.
that is 2 into v2 के जगह पे क्या लिखेंगे 2 u1 minus v1. Listen, no? और इसका स्क्वायर है, so टोटल का स्क्वायर कर देंगे तो कितना हो जाएगा 4 u1 minus v1 का होल स्क्वायर. So by solving this and cancelling one term, we will be getting CV1 is equal to U1. U1 is equal to 3 times of V1. We'll get this relation. And now the fraction of loss in kinetic energy for mass 4m. Now we'll find fraction of, right? Fraction of loss in kinetic energy. Fraction of loss in kinetic energy for mass 4m. Is change in kinetic energy by initial kinetic energy. Change in kinetic energy मतलब initial minus final divided by initial. So that is equal to initial kinetic energy कितना था? Half 4m u1 square minus final kinetic energy how much? Half 4m v1 square divided by half 4m v1 square. By solving these, students, I will get it as 8 by 9. Solve and we'll get fractional the energy lost by the colliding body A. How much energy is lost? Fractional loss of kinetic energy. So I'll get it as 8 by 9. This is the required answer. See here, if force F is equal to 20 plus 10y acts on a particle in y direction, where F is in Newton and y is in meter. Work done by this force to move the particle from y is equal to 0 to y is equal to 1. Friends, here force is given. Force is given how much? 20 plus 10y. And you know, students, work done. W is equal to how much? F, not dy. So let's put it. F is 20 plus 10y. F is 20 plus 10y, and that is dy. And the limit, you know, students, y is displacement is from 0 to 1. And by solving, you will get integration is 20 plus 20y plus 10y square by 2. 10 into integration of y is y square by 2. Limit is 0 to 1. So from that, I will get 20 plus 10 by 2. Putting the upper limits, there is 25 joule. This is the work done. Since a particle of mass 5m means initial at rest means it was having initial kinetic energy as 0. Got it? So initial velocity is 0. U is equal to 0. No momentum initially. Suddenly breaks on its own into 3 fragments. That means let it breaks and 2 fragments of mass m each moving along mutually perpendicular direction. So one moved in this direction having mass m. Another is also having mass m moving in this direction. Getting each moving along mutually perpendicular direction with speed v each. ये भी v speed पे जा रहा है, ये भी v speed पे जा रहा है. Since 2m gun, how much mass left? 3m, yes or no? Another mass is 3m. We don't know its velocity. Let it's moving with a velocity v dash. Okay. So this momentum is mv. This momentum is mv. So resultant will be how much in which direction? This direction. Yes or no? That will be how much? mv square plus mv square root over is how much? Root 2 mv, na students? Yes or no? This is the momentum, resultant momentum root 2 mv. And what will be its momentum in this direction? 3 mv dash. Yes or no, students? Got it? So students, from law of conservation of linear momentum, we could write 3 mv dash is equal to root 2 m into v. Got it? From there, I could know the velocity of v dash in terms of v is equal to root 2 by 3 into v. Okay, we got this relation. Next, students, ये क्वेश्चन पे पूछा गया है कि what is the energy released during this process? Right, energy released during this process. Energy released energy released during this process is kinetic energy is equal to 2 into half mv square plus half into 3m v dash square. Okay. So by solving this one, friends, we'll get it as due cancel, so that is equal to mv square, then plus 3/2 बाहर आ गया into m. Friends, v dash is how much? Root 2 by 3 v. So if I'll make it square, then it will be
2/9.
2 by 9 v square. By solving the total, I could get this is mv square, due to cancel 3 by 9 by 3, mv square plus mv square by 3. So that is equal to 4 by 3 mv square. This is the required answer. It's a moving block of mass m collides with another stationary block. Stationary means u is equal to 0 initial before collision of mass 4m. The lighter block comes to rest after collision. This means collision velocity v. The initial velocity of the lighter block is v. Then the value of coefficient of restitution. Friends, a moving block of mass m. This is a moving block which is having mass m. Let its velocity is v is given when the initial velocity of the lighter block is given v. Collides with another stationary block. Stationary block that mass is 4m and it is having no initial velocity. And after collision they collided. What happens? The lighter blocks comes to rest. That means the block which is having mass m, its velocity is becoming 0, rest. And let the heavier particle which is having mass 4m is moving with a velocity v dash let. Then we are interested to find the coefficient of restitution, students. Students, here final velocity of the lighter block is 0. Final velocity of the heavier block is v dash. Initial velocity of the heavier block is 0. Initial velocity of the lighter block is, let's let v. So applying law of conservation of linear momentum. So if I'll go for conservation of linear momentum, then I can write here momentum before collision mv plus 4m into 0. So no initial momentum of this is equal to 4m, let it is moving with v dash plus 0. Yes, student, from there by solving you will get v dash is equal to v by 4. Okay, this one I got. And coefficient of restitution, you know, coefficient of restitution, coefficient of restitution E is equal to relative velocity of separation, relative velocity of separation by relative velocity of approach. That is equal to, students, relative velocity of separation कितना है v by 4, क्योंकि इनिशियली 0 पे था, अभी v by 4 पे आ गया. So v by 4. Relative velocity of approach initially v पे था, अभी 0 पे आ गया. So that is v. So solving it, we'll get it as 0.25. So coefficient of restitution is becoming 0.25. This is a body initially at rest and sliding along a frictionless track from a height h. Just completes a vertical circle of diameter AB is equal to d. Height h is equal to how much? Friends, body is at rest initially, so यहाँ पर initial speed जो है body की 0 हो जाएगा. और यहाँ पर body की मान के चलो velocity speed at the bottom is becoming v. Friction is strike is frictionless, students. So total energy will remain constant. So total energy means, students, यहाँ पर total energy कितना होगा? Kinetic energy plus potential energy. Here there is no kinetic energy because initially it was at rest. So initial kinetic energy is equal to 0. Kinetic energy initial is equal to 0. And students, potential energy initial is equal to m, mass is m given g, and at a height h. And student, kinetic energy final is equal to half mv square. Right? And potential energy final is equal to, students, 0, because it is at the bottom. Potential energy final is equal to 0. So by considering this one, students, I will get initial total energy at the initial point 0 plus mgh, or that is total mechanical energy, is equal to half mv square plus 0. You solve, you will get h is equal to v square by 2g. But students, here we have to write in terms of d. Students, for completing the vertical circle, so the velocity just completes a vertical circle of diameter AB. Student, in circular motion, completing the vertical circle, V should be greater than equal to 5gr. Minimum speed required. Student, here by let a body is moving in a circular path like this. Let the body is moving. Students, by comparing the total energy at the bottom, comparing the total energy at the how much should be the minimum energy to complete looping the loop, जैसे concept, उसी से हम theory पे derive किए हैं. The V should be greater than 5gr. So by putting the respective value here for completing the vertical circle, so H is equal to, students, 5gr का square, root 5gr का square, that is 5gr by 2g. So that is equal to how much, students? 5 by 2 r. But it is given in terms of d. So r is d by 2. So 5 by 4 into d. This is the required answer. Let's consider a raindrop, drop of rain, water having mass 1 gram. So mass of the rain gram was 1 gram. From a height 1 kilometer, that is 1000 meter, it hits the ground with a speed of 50 meter per second. Velocity just before touching the ground is 50 meter per second. Value of g is 10 meter per second square. The work done by the gravitational force and the resistive force of air. So in this question, mass is given how much? 1 gram. Acceleration due to gravity is 10 meter per second square. And from a height that is 1 kilometer, that is equal to 1000 meter. And velocity just before reaching the ground is 50 meter per second. It is gram, we have to convert it to kg. So that is 10 to the minus 3 kg. Okay. So student, the work done by the gravitational force. The work done by the gravitational force. Hmm? The work done. The work done by gravitational force is mgh. That is equal to m is 10 to the minus 3, g is 10, h is 10 to the 3. So that is nothing but 10 joule direct. And students, total work done by the gravitational force and resistive force जो भी है वो पूरा वर्क किसके साथ सेम होगा? इक्वल टू द चेंज इन काइनेटिक एनर्जी ऑफ द रेन ड्रॉप. इनिशियली काइनेटिक एनर्जी मतलब कि फॉल्स फ्रीली 0 था. कुछ प्रोसेस के दौरान ये वर्क डन हुआ. वर्क डन हुआ तो फिर इसका जो काइनेटिक एनर्जी है वो पूरा उस पर कन्वर्ट हो जाएगा. So student, by seeing that, we could find the work done by the gravitational force is let Wg, work done by the air resistive force is Wr. That will be equal to the change in kinetic energy. Initially 0 पे था और finally जब ground पे पहुंचा तो kinetic energy half mv square हो गया. Yes or no? So that will be how much? 10 plus Wr is equal to half into 10 to the power minus 3 into 50 into 50. V is given 50. So by solving this, students, you will get the work done by the resistive force is equal to minus 8.75 joule. Okay. Here the correct option is C.